welcome to GDC Classes English. So today we are back with our MCQ series in which we are going to cover regarding the chemical kinetics. In the last video we have covered about the HLB scale, basic theory and questions. In this series we are specifically going to cover the MCQs from the chemical kinetics. So this series, as I have mentioned before, also will be really very helpful for you all for your exam preparation, be it GPAT, NIPER, DI or any government pharmacist exam. So you name it and that we have it, right? So this preparation is highly dedicatedly made for you all. So we have a request in return that you must place your feedbacks in the comments below. We do check them all and take it very seriously. So without any break, let's get started with our first question of the day. So the question says unit of rate constant for second order reaction. So this is a very simple way to answer this question. If you remember the simple rate equations from all the 0, first, second and third order, you are easily able to answer, right? Even if you remember the half-life equation for second order is what? T half is equals to 1 upon AK, right? So for this concentration of A, you need to calculate for the rate constant, that will be T half into the concentration, right? So I think for the concentration, the value calculation is not very difficult. It will be mole per liter, and for the time it will be second inverse, right? Sometimes we don't remember, so we can calculate, right? So for the time it will be second, right? For the concentration it will be mole per liter. Okay, so now because it is in the inverse, so it will be mole inverse liter into upon second inverse. So I hope it resembles what I have mentioned, liter mole inverse second inverse, right? So you can remember the rate equations or directly the half-life equations for their calculations. Second, so option A here is correct. Next question, half-life for zero order reaction can be calculated by. So again a very direct formula, right? So for the zero order it is T half is equals to 1 upon 2A, right? It will be around, sorry, A upon 2K. It will be A upon 2K, right? Then I hope you got the answer. For the first order, it is around T half is equals to 0.693 upon K, right? And for the second order, as I have mentioned, it will be 1 upon A into K. So this is for the second order, this is for the first order, and this is for the zero order, right? So we have a correct answer as option number D. Okay, direct questions are asked based on half-life, shelf life, expression for rate equation, or even the half-life. Next, which of the order of the reaction is followed by photo decomposition of drug? So these reactions, the photo decomposition, sorry, that mainly involves nothing but the first order reaction, right? They may ask you regarding any ADME processes also in between. So that follows also the first order kinetics. Next question. Half-life of the first order rate reaction is represented by the formula. First order, I have just mentioned it before. For the zero order, it was A0 upon 2K. For the first order, it was 0.693 upon K, and for the second order, it was 1 upon AK. So you have to check the correct answer. Is it 0.693 upon K? Is it 0.693 upon AK? 0.693 upon 2K. So we have the correct answer, option number 1. Okay, 0.693 upon K. So they may ask you this question likewise. Next, Arrhenius equation. Now this is the most asked equation. I repeatedly mention about this in my every class. So this is the dropping point for you all to please go study about Arrhenius equation. It is highly important from your exam point of view. Basically explains the relation of stability, right? As the reaction process progresses, how much of the reactant is remaining and then how much is converted into product, its stability. Secondly, it also gives the relation between the viscosity as well as with the temperature. So it's a very, very good way that you can cover. I am giving this a very important hit to note it down. So they may directly ask you, Arrhenius equation gives the stability of the drug, which is a plot of what? As I've already told you, that how the reaction progresses versus temperature. So it is going to be log K versus 1 upon T, which is the temperature. Okay, next question. Rate of kinetics deal with. Now this is again very basic question. So rate of kinetics basically deals with the order of reaction. Is it 0, first or second? How we have seen the equations. You know the rate equations and the half-life ones. Okay, next. In the chemical reaction, the rate constant is independent of initial concentration. Which one of them is the correct order? So as it suggests, it is independent of the initial concentration. So it's a very good hint you have got it, that zero order, in which we generally say the rate of reaction is usually independent of the initial concentration, right? So it will be none other than our zero order. Option D here is correct. Next, for the first order, the rate constant has unit. I have already told you, you can calculate the unit directly using the rate equation or memorize it, or even using the half-life. So for the first order, we had the half-life of 0.693 upon K, right? So we are for the K, we have only one parameter, but in inverse, so it will be nothing but second inverse. It will be option number D, second inverse. Okay. Moving on, next question. It says the equation in which used to predict the stability of the drug at room temperature from experiments at the accelerated temperature. Right before this question, I have already told you that the relation between the how the reaction is progressing, that deals with the directly with the stability of the drug. Now that depends on the temperature conditions as well from the Arrhenius equation, right? So the expression of Arrhenius equation is, and its aspect is very important, and we got our correct answer, option number B. Next, which of the following is considered as an external, that means environmental factor affecting the drug stability? So using buffer, which type of buffer? That will be a part of its composition and testing, so it is not a part of the external factor. Then we have the excipients. Excipients are also not external, but whatever drug is created, use the final dosage form requires excipient. Dielectric constant itself will be a physicochemical property of the molecule, so it doesn't have to do anything with the external factor, but it is more of its own factor. So we have radiation, which is quite outside, that means an external factor, right? So it is easier to find out. Next, the most common mode of pharmaceutical degradation is, now it is very simple. We all know that the drugs, if they can get a little of moisture, the dosage forms get spoiled, right? So there are very stringent storage conditions which are always mentioned on the package insert, right, which gives you the correct guidelines. The storage, the photolysis is there, hydrolysis can happen, moisture content, oxidation, any which way the product can get spoiled. So hydrolysis is one of the most important and easiest, commonest way by which the degradation can occur, although rest others were also the degradation ways. Shelf life of pharmaceutical product is computed by Fick's law, Arrhenius equation. 𝙂𝙀 is a release equation for the modified release dosage forms. Noyes-Whitney is the equation for dissolution, right? Fick's law is for the diffusion. So we have our favorite Arrhenius equation, which stands by the stability of the drugs. Okay. Option D here is correct. Next, the destruction of microorganisms is given by which of the following equation? So the destruction of microorganism by steam may be dependent on its concentration. So it is our first order chemical reaction and not a zero order. Next, which of the following order of reaction shows the fastest rate of reaction? Now this question can be a little incomplete also, because rate of reaction here, if you want to answer it the fastest, you must know about that the rate of reaction will be now dependent on the concentration. So the ones that we have a higher concentration will have a faster rate of reaction. Based on rate equation, you can see it is generally in the second order also, it is proportional to the second power of it, right? So it is just although it is very incomplete to say that this will be fastest, but yes, based on the concentration, we say second order will be the fastest. Okay. Next, drugs in suspension and semi-solid formulations follow which type of kinetics? They follow Actually, they follow pseudo zero kinetics, which is not the option here. So we have to go with the zero order kinetics. Why? Pseudo zero, why we say it? Because initially in the suspensions, you already know that drug is some drug is already sedimented, and we have a solution phase and we have a sediment phase. So that sediment phase is acting as a reservoir. That means supplying the drug continuously. So initially it is a first order, but that by the passage, as I mentioned, it is supplying a constant amount of the drug. So it becomes a independent of the concentration, then we get a zero order. So we have first order and then it is a turns into a zero. So we have pseudo zero order, right? Apparent zero order kinetics we say. It will be option number A. Next, determination of order by which method? So order can be determined by the graphical method, substitution method, or even half-life method. All of them are correct. Okay. Next, molecularity of a unimolecular. See, molecularity of a unimolecular. We have unimolecular, bimolecular, such type of reactions. The name suggests how many molecules are involved. So uni means single. So molecularity of a unimolecular will be none other than our one molecule. Okay. Next, in apparent zero order suspensions, the rate of degradation primarily depends upon, just now I have told you that it contains drug particles in the sediment phase and in the solution phase. So slowly from the sediment phase, the particles are being solubilized into the solution phase and then they seem to be degraded, and this supply is referred to as continuous supply, constant amount. So this will be a zero order. So it depends upon the solubility of the drug as mentioned clearly before. Okay. Next, pseudo first order reaction originally is which order? So pseudo first order reaction is originally a second order reaction, but out of which one component, for example in the hydrolysis of ester, it gets independent of the concentration of one reactant, and from the second order now it is left to the first order reaction. Okay. Next, shelf life T90 it says is the time taken for the concentration of a reactant to reduce to 90% of its initial concentration, right? So we have option B as correct by the definition. So that's it for today. I hope you all have answered the questions correctly. Please comment down your scores and I do check them all out. Thank you so much. We will meet in the next video.